Hello, this is Dr. Mears. Today we are going to be solving the inequalities and showing our work. We're also going to graph the inequalities on the number line after we solve them, so we can see where all the solutions lie. After you are done of this video, please glue into your ISN. Thank you. Okay, here we go. The first one is x plus 2 is less than or equal to 6. I apologize first if you can't see these numbers down there. It does go from 0 to 10. All right, so x plus 2 is less than 6. So here we need to get x by itself. It is linked by this plus 2, so we have to do the inverse operations to both sides, just like if we were solving a regular equation. So we bring down the x, we bring down the less than symbol. 6 minus 2 is 4. So x is less than 4. So what we're going to do is, this is a less than sign, so that gets an open circle on 4. And we have to think about all the numbers that are less than 4. Well, 3 is less than 4, 2, 1, 0, so all these numbers are less than 4. Okay. Next, x minus 5 is greater than 1. So we have to get the x by itself. It's linked to, the 5 is linked to the x with minus, so we're going to add 5, the inverse operation, to both sides of this inequality symbol. We bring down the x, we bring down the greater than symbol. 1 plus 5 is 6. This is a greater than symbol, so it gets an open circle because it doesn't have that equal sign underneath. Remember, if it had that equal sign, it would get the close, but it does not. So we have an open circle on 6, that's right here. It says x is greater than, so we have to think about all the numbers that are greater than 6. So 7 is greater than 6, 8, 9, 10, all of these numbers, so on and so forth. Next we have 2x plus 1 is less than or equal to 11. Again, we have to solve for x. So we see that this is a weak bond right here, so let's subtract 1 from both sides because it was being added. So we have 2x is less than or equal to 11 minus 1, which is 10. The 2 is linked to the x by multiplication, so in order to undo multiplication, we divide. So then we come out with x is less than or equal to 10 divided by 2, which is 5. Now we have a less than or equals to, which means it can equal the number. So we get to do now a closed circle over the number 5, and that's a closed circle on the number 5. We need all the numbers less than or equal to, so we have 5, 4, 3, 2, 1, so on and so forth down the line. Next is 3x plus 7 is greater than or equal to 19. So we're going to minus 7 from both sides because that is the weaker bond. We get 3x is going to be greater than or equal to 9, 7, 12. That took a second. So 3x is greater than or equal to 12. The 3 is linked to x by multiplication, so let's divide both sides. So we get x is greater than or equal to 4. So it's greater than or equal to, which means we can have a closed circle because it can equal 4. So a closed circle on 4. All of the numbers that are greater than 4 are 5, 6, 7, 8. So greater than or equal to 4, 5, 6, 7, 8, so on and so forth down the line. Okay, let's look at our special case. Special case 3, negative 3x is greater than 12. So we have to solve for x. This is linked by multiplication, so we're going to divide. So I'm dividing by a negative 3. Now when we divide or multiply, and it's a negative number, remember that negative goes with it because we're dividing or multiplying. But this symbol now gets reversed. It gets reversed like that. So instead of a greater than symbol, it becomes less than. So our special case, when we divide or multiply by a negative number, flip the symbol. So I divided by a negative 3. The negative does go with it. And when I did that, it became a less than symbol. So now this is x. That crosses out. That's 1x now is less than 12 divided by 3 is negative 4. So now what I would do is I would graph it. Here's negative 4, negative 3, negative 2, negative 5, negative 6. There's my number line. It's less than, so it's an open circle on 4. X is less than 4, so all of the numbers less than 4 are going to be this way, negative 6, negative 5, and so we're going to go that way. So there's our special case. When we divide or multiply by a negative number, you flip the inequality symbol. You can also say reverse the inequality symbol, and that's about it. There's one other thing that I would like to say, and that is to be careful. Each time we solved, x was on the right side, x. Be careful, because if it gets to the other side, if you're solving for an equation and x is on the other side, just be careful when you're graphing. So, for example, if you have something such as, an example would be, please write this down, 7 is less than or equal to x. So notice my x is not on the left side, it's on the right side. So this was on the left, that was on the left, that was on the left, that was on the left. So in order to graph this, I would put 7, 6, 5, 8, 9. It's a less than or equal to, so it's a closed circle because it can be equal to. And so this is 7 is lower, is less than x, which means x is going to be the bigger part because 7 is always going to be lower. So I kind of read this backwards. X is greater than 7. So I need all of the numbers greater than 7 because that's going to be the lowest one there. So this is just to be careful when graphing. Be careful when the x is on the right side versus when the x is on the left side, because all of these examples were the same where it was on the left side. So just be careful of that example, and be careful of our special case. This has been Dr. Mears, solving and graphing inequalities. Please glue this into your ISN. Thank you. Have a good day.